Also, thank you to PlantGENE for this opportunity and for allowing us to discuss today how we feel biology intersects with automation. Without further ado, I'll jump into this presentation. We already had such a beautiful introduction that I don't think I need to say more. But I would like to emphasize that I'm Suzane. I'm the lead of plant science here at Viscon, and I have Kelly supporting me today. And Kelly and I are part of Viscon Plant Technology, which is a business line from the larger Viscon Group, which is a Dutch-based automation company who've, I think, for close to 100 years now, prided themselves on being able to innovatively design, build, and fully integrate automation solutions in various different industries, from the hatchery industry to the plant science. Yeah, that's very exciting for us to be able to present on our thoughts here today. Before I jump into the actual presentation further, I'd also like to emphasize what we hope to answer with our presentation today, the goal of the different content we're sharing. And with that, we hope to answer 6 questions, of which the first is, are you automation ready? And I think this actually fits into a little bit of what Christopher, Vina, and Micah has mentioned already. So how do you assess that readiness? It's important to know exactly what you want that automation you want to implement, what you want it to do. So to define the objectives and the KPIs. Of course, Micah now really emphasized this towards the end of his talk, where he mentioned, that redesigning workflows, adapting a little bit, or standardizing certain things to also accommodate the current availability of the technology. Well, sometimes you need to make that choice, right? Do you buy the super fancy robot of $500,000, or is there at that point maybe a more feasible solution, the hybrid solution? And of course, balancing the cost, right? It's all of this still needs to make sense, and it still needs to result in a positive ROI in the end. But I think also something that Micah mentioned as well is that risk mitigation at the end. And also, you have those few roadblocks in implementing it. It might not go as smooth as you want at the start. And how do you actually facilitate that and get it implemented into your processes successfully? So I always start with the question, to automate or not to automate. And for those who've seen my presentations before, I think you're pretty tired of this. But I have my colleagues joining me on the webinar today, and I think they'll laugh because they're the ones who usually tell me, Suzane, we can automate you anything. We can build you a rocket that takes you to the moon if that's what you want. But usually, we don't really want to go to the moon because my answer is there are no plants there, right? So yeah, not really where I want to go. The key to a successful automation is really smart automation. And I love the word that Christopher used. He said thoughtful automation. And I'm going to coin that and steal it from him for my presentations in future, because I love the idea of, just emphasizing that you have to really estimate whether the automation and the solution you're looking at will boost your efficiency, automate that data collection that Vina was mentioning, and still deliver the real ROI. Now, I'm a part of the strategy and innovation team at Viscon, and we're the ones who build you all these fancy robots in the end that do the tissue culture and all the really complicated systems, we hope. So to be able to do that, we have a very specific R&D approach, and that is based on 5 different pillars, which is basically discover, define, evaluate, design, and build. Now, of course, this is not directly applicable for you guys because you are usually the people we do this process for. But when I looked at the process with my colleagues, we actually thought that this might be applicable if we take it from the other perspective. So for the rest of the presentation, I'm going to be going through these 5 pillars, but from your perspective as a lab manager or the person who's evaluating the automation, right? Maybe something Kelly mentioned that's really important also to emphasize. These are really steps and phases that in isolation could take time. And I think that's something that's often underestimated as well. it really is a process and it really is a flow. And I think it's important to take into mind that there is a roadmap, like Micah mentioned, and that roadmap is maybe something that takes a few years, but it's important to have your goal at the end so that you know that that roadmap and that time investment has been worth it. So starting at the first one, discovery. And I really, guys, as a part of the projects that we do, I cannot emphasize enough how important this step is. Really understanding the full process you're following and understanding each step you go through, as Micah mentioned, like, it's media filling up to going into the greenhouse. That is key to making sure the automation you're evaluating or the solution you're looking into will be a success. On the right here, I have an isometric where we actually show this, right? Where we map with our clients each step, and we can understand in the end how the whole process flows goes and where the automation might be needed. Because one key question we usually ask is, are you ready for what you hope to implement? So are you open to possibly having to change a cup? And here I have to thank Micah again, because you really set the scene for me on this example. But are you also open to maybe adapting a protocol to some extent? Because the devil is in the details. And again, you see the different containers here. And where we found in our innovations, it really being a key to being able to standardize. And I think this little guy has, featured before. So another aspect in the discovery phase, which we think is really important, is what we refer to as our Golden Trilogy. It's how the people, its environment, which includes the lab and the machines, interact with that organism and actually create a synergy. And the automation is not supposed to replace one of these items. It's supposed to facilitate this synergy. And it's really supposed to be able to create an environment where you have, happy people. That is the goal in the end. If we go to the next phase, so after you've discovered your process and those details and every step that you'd like to have a look at, we go into a definition phase where we say, okay, what do you want to automate and why? And I think in the previous presentations from Vina specifically and Micah as well, it's really feasibility versus desirability. You have to prioritize the high impact, low complexity at the start. So what's the low hanging fruit and what can I start with? And what are the clear KPIs of that? And what will it bring for me in the end? And I think here on the right hand, we have the example of the media filler, which Micah has also mentioned, and my colleagues asked me to add here, how many hours we spend in a lab filling media and how much FTEs or hours you're saving. And I just went like, you know what, I'm not even going to try and guess how much of my life I have literally wasted pouring media. So I've been through the academic stream. I remember days in my PhD where, other people are partying on a Friday evening and I'm pouring media. And then it's like hundreds and hundreds of Petri dishes. And my colleagues, when I started at Viscon, were like, you guys actually do that by hand? And I had like, there's a machine that can do this for me? You've got to be kidding me. So, right, also having that knowledge of what's available and what impact it can have if you directly implement it in your setup is really important. Also sometimes really important to remember, and this is again that question, do you buy a $500,000 robot or, do you have the hybrid solution? It's sometimes a little bit thinking out of the box. And this example, I actually have to contribute to a previous colleague of mine, but he used to say that, Suzane, if you're going to add a ball from one box to the other, you might want to have a robot that runs between the two boxes. But in the end, if you just push the two boxes closer to each other, you're also solving part of your problem. And I think that's also a different view that you need to have on automation, is that it could also be a little bit thinking out of the box and having more simple solutions than what you expected. Now we go into evaluation where we say, okay, great. We know our process, we see the pain points, we've identified what we'd like to achieve with our automation, but can we actually do this? And here we usually use what we call a traffic light system. So you'll start with the green stuff, right? Where you say, okay, low biological variability, standardized consumables, it's really automation ready or friendly. Let's go, no brainer, ROI makes sense. Then you have those orange ones where it's a bit like, I think in Micah's example, we'll have to standardize our containers, right? We can't use all the different containers anymore, but in the end, it makes sense. The sacrifice isn't too much on our process change, and we see the value of still investing. And then you get to Christopher's embryo rescue example, and you're a bit like, okay, maybe the technology isn't quite there yet. So, and this is also still a little bit too expensive. This is that rocket that will take me to the moon, but I don't know if I'm quite ready to get to the moon yet. And I think this is really key to the roadmap that Micah mentioned as well. You as a lab or as a process also need to have that roadmap and know, that everything might not be best possible today, but as Vina mentioned, we don't know what's possible in the future. And at the moment, technology is progressing at such an insane speed that it might be that in 2 years from now, the red becomes orange or even green. During the evaluation phase, I think everybody has mentioned also, that OPEX, CAPEX investment and having the accountants and your CEO happy when you go to them with the new proposal. So that's what we call the friendly ROI. And I again take the media filler as the most simple example here, where we would say, okay, it's roughly 10K. It's probably not, but this was the random number I punched in here. The problem is that often that media filler isn't just 10K. There's a lot of hidden costs that if this is your first time down this rodeo, you're going to be like, oh shit, wait, I have to still ship it to my location from, Timbuktu or from the Netherlands. That costs money. Maintenance, is there a service plan included? How often do I need to replace parts? Do I need to ship those parts to my location as well? This can also be a hidden cost. Energy input. We all work with plants, and plants need light, and light is energy, and energy is expensive. I think you also need to consider the number of people or operating hours you would like to increase efficiency on or deviate, and then versus what the machine can actually do at the moment. And I think that also links to what Micah said, like if it can meet the current capacity or increase, then great. But if it can't meet that capacity yet, then maybe it's not worth it. And then again, versus the wages per hour, which is very geographically dependent, you hope that in the end you come up with your friendly ROI. And what we often do during our development processes or engineering contracts is we actually sit with you and work this ROI with you. And that also makes it a little bit more digestible and less scary if it's the first time that you're going to implement such a large automation project. Then we get to the fun part, usually for us, and I think I need to speed up a little bit, but this is the design. And this is where we start to realize what we've been, brain farting the whole time up to this point. And this is where we really start drawing that machine or making a concept, and it's really exciting. We have proof of concepts. I think for you guys, of course, that's a little bit different, right? It's more where instead of going from the different iterations where you have a proof of concept, a pilot, you need to have site acceptance and you can scale up. This is really our process. But for you guys, I think what would happen in design is where you can actually start preparing your processes to implement this feasible option. What do I need to change? Can I start changing those processes? Do I already change my cups now? Do I need to shift some laminar flows to make space? Does this mean that the way my lab is laid out at the moment, I need to, preempt that a little bit? And this is really where in the design phase, we encourage you guys to think about how you can already anticipate the new implementation to make it a success. And then we get to the really exciting and super amazing part, the build. So now you have the friendly ROI, you have the KPIs, it's going to do what you want, so you can finally buy that machine. And for us, an example of this is actually the VitroFlow Select. It's a machine that we launched at the end of last year, which is a part of our somatic embryogenesis platform. And this is really where the proof comes in the pudding, and you have all that hard work into a system that actually generates you efficiency, scalability, track and trace, and everybody is finally happy at the end of the process. So I've added a little video just to illustrate, for example, what this machine does so that you have context to it. This is really a machine that's able to identify viable embryos and transfer it from a liquid media onto a solid media system. It has automatic product carrier handling, so opening and closing, and it all happens in a sterile environment. So this, I think, is where you touch on that idea of it already being a little bit more smart and being able to think. But for the somatic embryogenesis platform, what I thought was really key was here we looked at the different processes, and we identified 3 pain points, right? It was media filling, it was handling of your embryo material, and it's transplanting the resulting plantlets into the greenhouse. So we were able to design a machine for all 3 of those pain points, but the star of the show in the end was this little guy. And this is really what Michael also mentioned in his presentation. To be able to implement this platform successfully, we really needed to standardize the container. And insane, you know, small detail that was really not on the horizon at the start, but it became such a crucial part, and now we're very happy with this little guy. So I think this is really a real life example of how we've gone through this process with a certain client. We were able to go through all of those different scenarios, and in the end successfully, you know, implement this into a happy ROI and a happy lab environment. Coming from the point of view of the lab operator, this is a slide that's really mine and mine alone, and I really wanted to add in here because I have to work with the engineers every day, and they're on this call, so I can't gossip too much about it. But what I've always prided at Viscon is the fact that we are able to do that intersection. We do at our, to the extent of our capabilities, we're able to successfully integrate plant science with that technical knowledge, but also that software development. Because there are a lot of things that I don't know that the engineers are king of, and then there are a lot of things that I know that the engineers have no idea what's going on. And the thing is, that's where the key to this, I think, tissue culture automation or even lab automation lies. It's really about being able to bring those 3 together, finding that golden trilogy, and being able to, properly communicate so that you meet the KPIs you wanted. To end off with, I have a slide that I think resonates a little bit, I hope, with everyone on this webinar or on this conference today, is where we have to maybe start thinking that redesigning the industry or the way we think is also necessary to some extent. Because we often talk about now having these automation-ready solutions. What can we do to facilitate the technology and also allow for earlier introduction? I think another key part to this is starting to think out of the box, like Micah said. Maybe it's not just reinventing the container, it's also reinventing how we thought we had to grow the plant all these years. Another thing that I think is really important, which I notice now working at Viscon, but which I didn't experience when I was in the lab, is knowing what's out there. And the example that I gave was, I didn't even know there were machines that filled Petri dishes for me. And that was really sad. But yeah, for me, I hope that that was able to answer some of the questions that you guys had, and also in the end, you know, touch on some of the topics that we had. And I also hope, yes, I'm 30 seconds in time, so very proud of myself.